Okay, next section we're going to deal with is called polyatomic ions. Polyatomic ions is well, let's take a look at the word polyatomic. Poly, remember polygon, it means many sides. The prefix poly means many. And you see the word atom in there. So this is one ion made up of many atoms. Now, there's three types of bonding in chemistry. Ionic, covalent, and metallic. Metallic is just electrons of the same element being shared in a tight bonding creating them. It has not much of a chemical reaction or equation value. But the covalent part is actually what this is describing. We're not going to get the covalent compounds until the next chapter, but the idea is a bunch of ions that are mostly, but not always, but mostly non-metals are going to covalently bond together to form one gigantic ion, usually negative. There's one positive ion, that's NH4 positive, that are known as ammonium. But the other ions that we're going to look at in just a second is going to be a gigantic negative ion that's going to latch onto a positive ion. Okay? So let's take a look at the polyatomic ion charts and see what we're talking about. Now this is a list of polyatomic ions that we're going to be dealing with. And you notice they're all negative, but the one that has a positive charge is NH4 positive 1 charge. Okay, and we will be using that occasionally. It's a fairly common ion. The peroxide we're not going to be using, so we'll ignore that one. But all the others are pretty common. So you don't have to memorize this. This is just going to be a chart that you're going to be using a lot, but I guarantee that you're going to remember a lot of these ions with the vast number of times that we're going to be using this chart. Regardless, this is the basis of what we're dealing with. Now, what we're about to do is we're going to create compounds, ionic compounds. Now remember, the definition of ionic compound is a metal with a non-metal. In this case, it's going to be a metal or a positive ion with a non-metal or a polyatomic ion attached to it. Okay, and the one example, or the one exception to that is ammonium, which would be a metal-like compound, no metal in it, but it's a positive ion, combining with any one of these right here, or just an element. Okay, so what we're going to do is we're going to come up with names and formulas based upon their opposite components. Okay, so let's take a look at some examples here. The first one is this compound. And we want to know what is the name of that compound. Well, every ionic compound has a positive component and a negative component. Metals are always listed first, or positive ions are always listed first, so we know that this is going to be listed first. Now that's a lowercase o, so you got to be careful of that. Now, when we deal with the elements here, that's this element right here, it's cobalt. With capital O, that's a completely different substance. But lowercase o is important to distinguish from the capital O, so don't get confused by that. Okay, so we're going to start off with cobalt. Now, the next thing we got to do is ask ourselves the question, is cobalt a transition metal? Well, let's go back there and see if we can find out. Well, cobalt's that sea of blue in the middle right here. That's definitely a transition metal. And what that means, of course, is that it's going to have a parenthesis and some Roman numeral in the middle of it. Now, the negative ion is this whole collection. Now, don't divide up the nitrogen and oxygen, say nitride oxide or anything like that. The fact that this is encased in parentheses in the two emphasizes the fact that this is one gigantic polyatomic ion. So we got to find NO3 on the periodic chart, or I'm sorry, on the polyatomic ion chart. Find NO3, and it's right there. It has a charge of -1. We'll get back to that a little bit later. But the nitrate is the name of the NO3 polyatomic ion. So this is going to be nitrate out here. Now we need to figure out what the charge of the cobalt is that's going to go in there as a Roman numeral. Well, we just found that nitrate has a charge of -1. And we have two of them. And this is the -2 charge. We also know that the charge of the cobalt plus the charge of the two nitrates together has to add up to 0. So that means -2 plus +2 will give us 0. So that means we're going to put this right here as our Roman numeral, and there's the name of our compound, cobalt 2 nitrate. Okay? Next example, we're going to take a look at this compound. And we want to come up with the name for that. So, Pb, that if you recall from your first chapter of elements, is lead. Okay. Is lead a transition metal? Well, let's see here. Go to the periodic chart. Lead is found over here in the right-hand side of the main group elements, which means it's not a transition metal. So we don't have to worry about a parenthesis. So we'll just leave the parenthesis out of here and then find the polyatomic ion ClO2. Now remember, the 4 is there just for the charge's sake, to balance these charges together to give us added 0. We don't care about that now because we don't have to have a transition number here. If this had been a transition metal, we'd have to go ahead and go through the charge of this times 4 and then figure out what that is right there. Don't need to do that. We don't need a parenthesis and we don't need a Roman numeral. We just need to find out what ClO2 is. So go back to the polyatomic ion chart. And there is chlorite right there, ClO2, chlorite. So, you just put chlorite right there. And that's it. Pretty easy, just like the binary compounds we dealt with before. Of course, these are not binary because you have more than 2 elements involved in these compounds. The next example is we give you the name of the compound. This one is platinum 3 carbonate. Okay, so we find platinum, and sure enough it's a transition metal, that's why that is there right there. So we know that Pt, or platinum here, has a charge of +3. So Pt has a charge of +3. Carbonate is a polyatomic ion, so we need to find that. Carbonate is right there. It's a charge of -2. The formula is CO3, so we need both those pieces of information. So CO3 and it's -2 charge. Remember, this 3 tells us the charge of the metal. That's what makes this a lot simpler than it could be to get to a fission for a charge. It's right there in front of our faces, slapping the tip of our nose. Alright, now we look at the two charges, +3 and -2. They don't add up to 0 by themselves. You're going to have to do something to each of them. So the lowest number that 3 and 2 go into are 6. So I multiply this by 2 to get +6. I'll multiply this by 3 to get -6. And you get P, T, and then this 2 right here goes to the subscript. Now we're going to have 3 CO3s, so I'm going to have to put the entire CO3 in parentheses. Anytime we have more than one polyatomic ion, we have to put parentheses in there. If we have only one polyatomic ion, we don't put any parentheses there. And then this 3 right here goes right there. And there's your formula for platinum 3 carbonate. Now be careful. You don't put parentheses around polyatomic ions if there's only one. But when there's more than one, you have to have the parentheses. Okay? Now I'm probably going to say that 150 more times, and about 30 you're just going to put parentheses around a polyatomic ion. Please don't do that, but I'll let you know when you fix it. Last one. Last example here is this compound right here, and we want to know what is the name of that compound. Okay, so we start with the positive ion, NH4. NH4. How do I know it's a polyatomic ion? Because I have more than one, and I got 3 of them. So that's a polyatomic ion. That's that one particular polyatomic ion that has a positive charge, NH4. Now that's not a metal. That's why they don't have a charge there. Or, I mean, we're not going to have a charge there. We're just going to put down the name ammonium for this. P is by itself. That is not a polyatomic ion. So we've got to go to the periodic chart and find P right here. P is a non-metal in group 5A, which is 3 away from 8. That gives a negative charge. Well, we don't care about the negative charge because there's no parentheses. But what is important is that it's a singular element that is negative. It's the negative part of the negative 3 that's important, because that means we have to change the ending of the name of the element to IDE. So this becomes phosphide. Okay? Those are your examples of how to do the practice problems. Practice problems, I say? Why, yes, we do have practice problems. Funny you should mention that. We've got 3 in which I give you the formulas you give you the names for. And I got 3 in which I give you the names for, you give you the formulas for. Have fun.